over time, I expect robots to be that intelligent using the data from simulation. So the robot will start to generate its own mission based on the knowledge and the information you can get out of the digital twin.
Welcome to a brand new episode of our podcast, Human and AI, Minds, Machine, and the Great in Ascent.
Thanks for tuning in to our geeky podcast, where we discuss the fascinating field of AI and machine learning, corporate craziness, passion for technology, and the role of humans. We are Uli and Avery, your hosts for this episode.
And now let's dive into a topic that has been always quite emotionally discussed, specifically in the general public, I guess, along the hype of and buzz on AI. Let's talk about autonomous robots. Market size, autonomous mobile robots has been estimated in 2023 be valued of $1.8 billion and expected to grow by a CAGR, as we call it, right? And a growth rate of 17%. So reaching a market valuation of $4.1 billion in 2028. So that's big market, big money, and quite some numbers.
Yeah, AMRs are certainly super exciting. So let's dive deeper into the field of AI and robotics. And Uli, you know what? We got just the right guest, an expert in the field with us today. So get ready to meet Péter Fankhauser, whose vision is to create a workforce of autonomous robots. Péter is driven by a passion for technological advancement and a desire to create a positive impact for society. Péter developed perception and motion planning algorithms for legged robots in challenging environments at ETH Zurich and is now the co-founder and CEO of ANYbotics. Péter, it's so great to have you.
Thank you so much, both Uli and Aubrey. Pleasure to be here today.
So I guess to keep things fresh and fun and also appeal to the Gen Zs in the audience,
Is there a Gen Zs in the audience? Hopefully, press like, press comment, right, if you're Gen Zs in the audience.
No, for sure. So let's kick things off with some hashtag magic, maybe. So, Péter, what 3 hashtags would you use to sum up your awesomeness?
Appreciate it. So I think that the 3 pillars that I right now focus on, number 1, hashtag entrepreneurship. Building a company, I love creating things, building new things, just being out there and see what can be done. And so this is a life passion for me, building ANYbotics together with my colleagues. Hashtag 2 would be technology. I am a geek. You mentioned in the beginning, it's a podcast for geek. Love that. So robotics is in the center of what I do. I did my master's studying robotics, my PhD, and have been following that for a very long time. Some people even call me a robot. I'm very logical and data-driven, try to be that way. So certainly there's that technology sense. And lastly, I really strive to create hashtag impact. So for me, just technology for technology's sake, it's not the main topic. It's about creating impact for people, the environment, essentially making the world a better place. So for me, really concretely, putting a smile on people's faces. This is what gets me up in the morning. This is what I do.
I already have a smile in my face. I'm listening
yeah, me
to
too.
You because that's pretty dope. Péter, great to meet you. So there's a saying, and it also resonates somehow with my wives and my kids at home. They say, I want an AI to do my laundry and dishes, not my writing or any creative task, right? So can you help us? So when will my shirts be folded by an affordable robotic systems, right?
Right, if I had a penny for every time that question was asked.
Yeah.
Let me tell you a little bit of an anecdote.
Okay.
Interestingly, we sometimes underestimate what a robot can or should do or how hard it is. So the home is, especially if you have a home with kids, it's one of the hardest challenges in an environment for a robot to navigate. What seemingly seems very easy for a human is often very difficult for a robot. So until we have a cheap, versatile robot that can not only do your laundry, but dishes, all of that, I'm not sure if that's, the right format, but it certainly will take many, many years until we get there. However, robots are already here, right? Sometimes we forget that in manufacturing, if you own a car, it's been built by a robot. If you get a parcel from Amazon, They have 750,000 robots moving your parcels around. And now robotics coming to the next level, industrial work, wherever you have people doing a lot of work in the power, in mining, these kind of environments. So robotics is here, not in our home yet, or doing your laundry. But I think it's a very exciting journey as we observe robotics entering more and more environments.
And why did you decide to go into the field of industry, whereas staying in the home market?
So where we came from is I joined a group of researchers at ETH Zurich in Switzerland, where our vision is to take robots out in complex environments. And for us, this meant we build robots with 4 legs because they can move anywhere where people can walk, meaning they can climb over stairs, steps, move into narrow environments, move in all directions. There's this fascinating form factor that allows robots to conquer new environments. And what happened is that quite soon, once we published that research work on YouTube videos, that operators of facilities contacted us and say, look, what you have here is very interesting because we need the eyes and ears on side of our facilities. We need to send people in to observe if things are productive and safe, but we don't have enough people to go around. It's very hard to find those young people who can and want to do those types of jobs. It's often very remote and dangerous situations. And actually, people are not great at constantly doing the same things. Our eyes and ears and our brains that cannot process that large amount of information. We cannot pick up all the signals. And so we had the technology, and we also really fell in love then with that problem. I spent the first couple of months and years at these facilities, learning the ins and outs. And I think it's a match made in heaven to help the facilities run the facilities more sustainably and productively while helping the people that are there.
And having you in this podcast today also feels like a match made in heaven. And you just touched upon what ANYbotics does and is, but we also read that you were just ranked as one of the top 5 hottest companies in the field of robotics and AI by HB in 2024. So congratulations on that. Can you give us maybe an elevator pitch of ANYbotics? So what's really your mission? What's the unique challenges that you're tackling in the field of robotics? So we are really curious to hear more about that.
Absolutely. Companies in the future and today will not only hire people, but they will hire robots to get the job done. So our vision is to bring robotics into industries that so far could not profit of robotics. So we work essentially to create the workforce of autonomous robots to help the critical infrastructure. Imagine power, utilities, sewage system, construction sites, oil and gas, offshore, wind farms, solar farms, nuclear industry, right? All of those facilities, which requires tremendous amount of manual work. You have constant presence of people. We help those industries to run their facilities more safely, more productively, and more sustainably. And how we do that is by extending the human workforce with a robotic workforce. So we build today 4-legged robots that are fully autonomous, meaning that you can install them once and they can do the tasks multiple times a day by themselves. And what they do is collect data. This is step number 1. They use high-end sensors, imagine cameras, thermal camera, acoustic sensors. So it's often the sense of seeing, feeling, hearing, and we replicate that in a robot. Now the robot can do that, for many, many hours without getting tired. It can see more than the human. It can see, hot spots. It can hear sounds that we don't. It can smell gases that we don't. And they can then combine that data and then immediately report on any anomaly. So the trick here is how quickly can you find a problem in your facility, report that back such that the human can then look at the information and to take the right action. That reduces the maintenance work you need to do. You can stop unplanned downtime and you save a lot of energy by finding leakages early, and eventually you can avoid accidents.
Super cool, actually. So my favorite digital ethics dude is Floridi. I don't know, Italian, UK-centric ethics. And he says, in a world of AI, we actually geofence. So we are not living in a world of, overlaying AI intelligence, let's say also robotics, but we actually separating, we fencing it out, right? That means if you go in a manufacturing site on a factory, right, there's a robotic system there and moves vehicles and or, parts and pieces, tons of of weight, but it's actually separated and fenced out there. It seems to be your approach is somehow a bit of a different angle, like overcoming the, let's say, the clear separation that this is where I place the field and here is where the human plays in the field. There, what's your stake on that, on these kinds of separations?
Totally makes sense in the beginning to look at it separately because these are still machines that carry a lot of energy. So safety, is a key aspect. Now, in the industries that we work in, and imagine, multiple floors, metal, but it's still outdoors, but there's stairs in between. It's a very, condensed and complex environment. There's going to be humans. And so to be able to send in robots into that environment, they need to be human friendly. And the humans also need to be taught how to deal around robots. So it's meeting of those two work groups. So yes, they will be sharing safely the same environment, but they're not going to do the same task. So it's still about making sure that what are humans really good at and separating that from what are robots really good at. It's not about replicating that. So human is creative, it's intuitive, right? It's flexible. We're much smarter. We can adapt to new challenges, and we're also individual. Every person brings in their strengths to the work. Robot, on the other hand, is very predictable, right? It's very logical. You know why it's doing it. It's much more precise than human. It's also consistent and repeatable, meaning that if you take one robot out, you replace it with the same model, it'll do the same thing, right? So it's about understanding how, what are the capabilities of humans and robots and putting them in the right, at the right tasks. But yes, they can share the workspace and coexist and collaborate with each other.
Super cool. So speaking of USP, maybe, what makes ANYbotics so different from its competitor, right? Or is there a specific aspect, achievement, milestones, you're super proud of?
Yes, I think fundamentally, and when we came out of the university, what we saw is the biggest risk of such a company is that you continue what you're doing and just, continue researching. That's fascinating. I would love to do that, but it doesn't lead to that impact that I mentioned in the beginning. So for us, it was very important to, from the beginning, be very customer-centric and understand the market. And that has led us down a path of very, interesting, unique value propositions. And so, for example, we were the first ones to really deploy very focused these four-legged systems for industrial inspection. That's a market we uncovered first. We then built very specific robots. So our robots are water and dust proof because we understand that these are systems going to be used for a long time outdoors in rainy environment, in corrosive environments, offshore saltwater, in dusty environments. So we built the architecture to cater to that industry. Then quite soon we learned around the needs in the chemicals industry, in the oil and gas industry, where there's hazardous substances, explosive substances. So you're not allowed to ignite a spark. So that's why we're the world's first and only company building an X-proof, called an explosion-proof robot for these environments that is of the legged form factor. And then, there's more topics which make us unique, such as, our autonomy is extremely powerful. We believe that a robotic fleet can only work when autonomy is at the core, and one supervisor can look at dozens of robots at once. And so how we then also integrate with digital twins and simulations has been a pioneering topic for us.
I wonder, because what you're up to is such a huge topic. I guess it probably takes a village to really build on that vision and continue like making those robots better and better every day. So what role do partnerships and your ecosystem actually play in the development of ANYbotics? And what role do other partners play in that?
Absolutely. Robotics is very complex. So we have to focus on the things we're really good at. So if somebody else can do, we shouldn't do it, right? So this is where we partner. So for example, on certain components, we're collaborating with Maxon. That's a Swiss motor company, because we built our own motors in the beginning, but then quite soon you realize there's others. We bring in certain IP, but in a collaboration, we can build a specific motor that's really optimized for our robot. Then simulation tools, right? There we work closely with NVIDIA to get ever closer to bridging the gap between the reality and simulations. It's with AWS for all the data storage, cloud architecture, these topics. And then it's certainly with partners like Siemens. It's about the go-to-market integrations. It's the domain expertise that we don't have. So let's partner with those excellent partners, those companies, to make what we have even bigger and scale it around the world.
So if we took years and century, maybe a couple of more centuries backwards, right? Robotics has been always a great field, right? And from early days, and I just learned that a mathematician, Achitas of Tarentum, actually postulated the first, a bit of somehow the first Pigeon, robotic system, which was propelled by steam, at least on on the chart it seemed to be, right. And then you have obviously the famous Metropolis, and then you have all the movies inspired, let's say, aspects. Maybe spinning out of ETH, right, and seem to be the first experiments, the first launch, but also things, the first tangible piece of robotic smart, whatever smartness was there back in the days. In 2009, I think it was called Aleph.
Right.
And now your current version seem to be, since 2021, Animal Gen D, right? Generation D, I guess, right? What actually has changed, right? Can you summarize from the
Everything.
first
Yeah.
prototype? It's like, well, it's still a thing, but it's just a different shell now. I
Right.
guess not, right?
I'm happy to take you a little bit on, a spin of the history. The first robot that we built, Alof, in 2009, was just showing the world that you can build a four-legged system. Now, we took very classical component off the shelf, classical industrial motors, a gear, electronics, lots and lots of cables, right? And we were able to show that the robot could walk on four legs, but you have to imagine it a little bit like a walking table. Very stiff, no adaptation. It wasn't, if you look at the dog, it runs around, it climbs, it's much more athletic and dynamic. So on the path to what we have today, there certainly have been three topics that happened through us and through the environment. So number one is how to build the actuation, the motor. How do that actuation system? What we realized quite soon is, if you look at the dog or even humans, it doesn't matter so much where is your foot placed at. It's much more, can you feel the reaction to when you step down? So if you walk on concrete versus if you walk on ice, your foot will slip, but you react very quickly to it and you walk more carefully. That reaction is determined by the sense of touch and your muscles that they're not stiff, right? They're elastic, because so that they can elongate and be compressed. So that systems we replicated on a robot. So we added springs to our motor. So instead of having a stiff motor and the gear, we add a spring in between that's quite flexible. Now, as the robot walks, that allows you to measure the force, because you can measure the deflection of the spring. It allows you to store energy as well, right? So if you jump and walk, the spring can store energy. And it also allows you to walk dynamically, because if you have impact of the foot on the ground, it doesn't shake the whole system, but it softens that landing. So that was one of the key elements, this force control and elasticity in the springs, that led to firstly a dynamic robot that could jump and run. Now that system is blind then at the moment. So you can do things, but it's only in very controlled environments that you pre-program it for. The second layer then is the perception. How does the robot start to see? And there has been a great revolution on making cameras smaller, is on LiDAR systems. Cameras today, it's quite normal for us to use Face ID on our mobile phone, structured light, stereo camera, these kind of topics. We could then use these technologies for the robots to start to see not only pictures, but see in 3D, understand the world, understand where do you place your feet, how do you react to obstacles, and that really allowed then the robots to become autonomous. The third piece that I'm really excited about is the AI. Now, in a traditional sense, we have been programming the brains of the robot, but that, you can do it, but you end up at the human's creativity to define all the rules and how to do that. Really, the magic kicked in when we allowed the robots to learn by themselves. And so they optimize based on a policy, on an expected outcome. Their neural network can get better and better. And with the existing hardware, we can show that, the systems massively outperform what a human could come up manually.
Super interesting what you just said. And one of those layers you were mentioning were around sensors, and that they changed in shape. And I also remember from my trip to San Francisco, like the self-driving cars, like the Waymo cars, that suddenly you have LiDAR sensors, and they're like so small that they can fit on a car. And I wonder, what's your perspective on the role that innovation has played over the past years to to make advanced sensor technologies more accessible, I also guess. So what's your view on that?
It's a massive enabler for robotics. Robotics is always a mix of different disciplines. So we take the newest technologies in actuation, in sensing, in battery, in compute, all of that, and we combine that to a robot. So whenever there's something, exciting new technology in the market, it will have an impact on robotics. So for us, the miniaturization and also the commoditization to a certain extent of LiDARs, of depth cameras, time of flight sensors, all of that has massively contributed to what robots can do today. So instead of them being fixed, right, and in a cage, as you mentioned in the beginning, just doing a repetitive A to B task, to be safely to work in an environment where also there's people, you need to understand where's a person. You need to react to a changing environment, and these sensors have played a massive role. So for us, it's about the combination of different modality of sensors as well. There's no best sensors for robotics. So typically you deploy a set of different ones. We use often depth cameras and LiDARs, fuse the data, optimize for its environment and the tasks, make sure it can perform the tasks autonomously, but also reliably and safely.
So speaking on a bit of an AI and tech stuff, right? Gen AI is obviously everywhere, right? Nowadays, everybody talks about, ChatGPT and different generative AI aspects. And there's, I guess also, from a large language models or foundation models, quite interesting stances, even so it never picked up. Obviously, it's picked up in the consumer industry, in service, maintenance, sometimes in engineering. What's your view on such foundational Gen AI tech stack like Palmi or RT2 and these kinds of stuff? Is that something you follow up? Are you contributing actually to open source stuff as well?
So we are contributing to open source topic. We're in GitHub, so there's a couple of projects there, certainly. Now we're also contributing to AI a lot, again, with partnerships. Our take is we're not in the game just to come up with the greatest AI technologies. We're in the game of taking the best technologies and applying them to our customers. Now, these large single foundation models, very intriguing philosophically. Okay. I've not seen yet the results that that we can deploy them in operations. So they haven't reached that maturity. I believe one of the tricky parts here is the data. So if you really deploy one foundation model, you need so much data from a physical robot in the relevant environment that doesn't exist yet. Eventually it will come. However, our approach here is actually to look at a smart architecture of a specialized models, which are much, much easier to train with less data. So for us, this means our robots' mobility is trained with AI in simulation, where we can do that. We use AI in the navigation to perceive the environment, differentiate between objects and calculate a path. We use AI a lot, obviously, in the inspection, right? How do you turn all those images into valuable insights? Nobody wants to look at 8 hours of video. So how do you take frame by frame, look at what's good, what's bad, detect objects and read out the state of the environment? So that's the inspection results that we're doing. For us, this means it's a large architecture, smart architecture of these specialized models. Then we feed constantly with new data from the field. Eventually, this might lead in a large foundation model, but for the moment, this is really the approach to go that we're taking.
Yeah, maybe we jump directly, right? So ANYbotics has been leveraging simulation, digital twins, somehow an industrial metaverse. Siemens sometimes also push it also with additional aspects to train AI in robotic systems. How does this contribute to the training and development of the robotic system? Can you guide us a bit of the learning, the performance? How do you compare it to traditional models? How does the pipeline work? To add to Robert, what is? Can you give us a bit of insights?
Yes. So for the users who don't know, kind of the deep reinforcement learning, what we do is essentially define, and it's very similar as a child learns to walk. Now, there's a parent and says, hey, come here, and the baby tries in the beginning, falls and struggles, but over time it learns from that experience and gets better and better. For a child, this takes multiple months and a lot of crashes, right, and learnings, but eventually gets there, becomes really good, but it takes a long time. It's the same system. We give our robots a policy, we give it a task and say, this is what you optimize for in terms of speed, stability, lift your feet sufficiently, walk over the terrain. So this is a mathematical rule we give it. And then the robot starts to optimize and converges an artificial neural network over time. Now, theoretically, we could do that on the real robot. But again, that would take a lot of robots and a lot of time. So instead of doing that on a physical robot, we do that in simulation. There you have to imagine 1,000 robots, right? We can have as many as we want, also accelerated in time, practicing around, then sharing the knowledge among each other in next round. So these days, with help of simulation, we can train from scratch an artificial neural network for walking within 30 minutes to 60 minutes.
Oh, that's pretty cool. That's actually pretty cool. So that means you have, I don't know, cloud services that trained on individual simulated environments, but on individual capabilities or maybe even broader scenarios like walking. And then for each customer, you have certain kinds of, specifics, I would say, right? The one who needs to, I don't know, identify corrosions or defects or holes or, from those kinds of use cases, right? And then in addition, tie up certain kinds of customization per customer project, or is there, hey, it comes already with the, sheer capabilities, that strands to the individual customers, and that's why, you scale on customer sides already.
Yeah, you touch up on a couple of topics. In terms of the mobility, what I described, training the robot to walk and also navigate, it's always the same model. There's no customization needed. The reason is that in simulation, we can have a huge, different types, number of environments that we can replicate essentially everything. And, independent of the industry that we work in, typically the stairs, the railings, the step, the cable, all of these things look exactly the same. Independent if you're in a nuclear facility or a water treatment plant, looks pretty much, very similar. So in terms of the mobility and navigation. Now, the second topic you mentioned is inspections. Also there, we find the typical tasks of turning kind of like analog gauges, lever positions into digital signals, same. Hotspots for rotating equipment, pumps, same topics. Acoustics, these kind of things are replicated. But you're right, then there's a long list of things that, are industry specific. For example, for the nuclear industry, you want radiation mapping. So what we did in the beginning is provide the core inspection capabilities out of the box, the ones that are cross-industry, and then start working with partners that are specialized for specialized industries. Now, the beauty is that the robot has compute on board. It has the relevant sensors often. We can carry extra payload to do that. So we're continuously extending the capabilities of this robotic worker with new, skills. So the further we develop, then we can also, the customers can extend the capabilities of the robotic workforce and then across the fleet. So, once we trained the systems, we can give it to all the robots, and that's a magical scaling moment.
Super cool. How long does it take to train an animal?
So for mobility, it's under 1 hour. And then for inspection tasks, you typically have a couple of hundred sample images. It's less about the training than itself. Once the pipeline is there, it's about collecting the data, number one, but then it's also validating, ensuring the model really does what it does. We ship every roughly 6 to 8 weeks. We ship a software update to the entire fleet over the air, so you can expect your robot to get better and better over time.
Can you share specific examples or case studies where the usage of digital twins and simulation led to significant breakthroughs or improvements in your robotic system?
Typically, how we set up the robot, the autonomy, is that we take a tablet, we take the robot, and we walk with the customer, the operator of the facility, through the facility and replicate what humans do today. So you manually control the robot back and forth, sideways, you let it climb the stairs, but then you point the cameras at certain elements and you say, record, record, record. Within that process, which takes a couple of hours, the robot creates this understanding and its own digital twin of the world and can then, you can edit that and essentially execute those missions. Now, if a customer has a digital twin already, we can use that for two things. We can simulate already the mission in advance. So tell the customer how long it's going to take, what's a good viewpoint to look at those elements. And then we can train the robot in that environment, set it up, and then bring it on site and just let it run without that installation process. Now, we had a couple of examples where the customer had really good digital twins, which are accurate. Within the first 10 minutes, the robot was already navigating that environment. It has never seen it, but it was able to leverage all the data available through the digital twin. And then obviously that's a magical moment where you can truly, massively accelerate the robotics commission process.
That's super cool. So if we look a bit of ahead, right, on the role, if you bring it on the next level, let's say in simulation and digital twin technologies, right, in AI and robotics, what future developments or trends do you anticipate in the space?
Yeah, imagine, the robots will, have seen thousands of facilities over time. So they become also really experts. Now, in simulation, you'll be then able to have the robot generate missions by themselves. Today, it's still a human in the loop telling the robot what to do. Over time, I expect the robots to be that intelligent using the data from simulation. So essentially, you open the box, you turn them on, and the robot walks around and tells you, these are the 200 things I found. Is that correct, right? And you say yes, you adapt, you work with the human on its creativity and decision-making, contextual understanding, but the robot will start to generate its own mission based on the knowledge and the information it can get out of the digital twin.
Yeah, this notion of autonomy, right, seems to be you found your key, let's say, key vertical or your key industries, but it seems to be very adaptable, right, to others. Are you keen on taking over the world, other industries, or do you think in other world around actually where it's around? So I think other industries can benefit from your capabilities that you develop, right? Do you have any thoughts on that?
Absolutely. I mean, I think fundamentally what we're building is extremely versatile. And we need to be extremely focused as a small company. So this is where we honed in on those core verticals. Long term, I see tremendous potential in the construction industry, measuring the progress, comparing that against the digital twin. Are we actually building, the right thing here and detecting deviations super early? I'm excited about agriculture, right? There's so much manual work being done. So that's a huge topic. Cleaning, switch systems, these kind of utilities, extremely interesting. So I'll believe over time we'll see more and more robots enter these seemingly unroboticized tasks and take over more and more of the work.
So exciting times ahead for sure. What I'm also interested to learn is what's your perspective on the growing emphasis of deploying robots and human-facing roles? Because you also mentioned earlier that humans and the robots are really meant to coexist in the same places and spaces.
This is a very important topic that we super actively work on. Fundamentally, what needs to happen for robots to be accepted, they need to be trustworthy. Very similar. That's the ground, the ground rules of also human interaction. It's the trust for high performance teams. And so for us, what this means in a robotic system is, number one, the robot needs to be transparent. You need to understand what it's doing, why it's doing. If it's not working, why is it not working? You can help it, right? Number two, you need to be still in control and have the sense that the human, if it doesn't work, you can turn it off. There's an off button, you can shut it down, so it will not compete with you in terms of the intelligence. So being very clear from the beginning how to interact with a robotic system. And then it's about the social connection. For us, this means the robot has a face, it has an eye, it has a little, smile on the face, being a approachable and not creepy, but rather an approachable, nice coworker that you appreciate. Often in the process of deploying robots, our customers give it a name. It's been very important, right? They run around and then they have a little competition and say, okay, how do we name this robot, Rosie or whatnot? They sometimes build a little doghouse for it, right? That's all part of welcoming your new employee. That's super, super important. So often we see a very quick transformation from initial skepticism to like taking selfies, putting it on social media because it's our new coworker, Felix, whatever name they give it. And so that is a fundamental moment. You need to give people time. You need to take them on the journey, and then it's truly, a mix of human and robotic workforce.
Yeah, and this way it also becomes more approachable, I guess, like if humans are also part, like in the process of like giving it a name and welcoming it, and probably it makes the adoption certainly easier. You already mentioned what verticals you see in the future for robotics applications, but generally speaking, what do you see does the future hold for AI and robotics? What are you most excited about, and do you have a moonshot in mind?
Yes. So today we're all about the inspection, collecting data. That's a very important routine tasks, and so everything we do is based around that. However, robotics can do much more. Instead of just perceiving the environment, we can start to interact with the environment, right? So manipulation is also at the core of our next development work. Imagine, an arm or multiple arms on top of the robot to do simple things such as pushing a button, turning a lever, taking a sample out of a chemical tank, right? These kind of tasks are everywhere. There's still, tremendous amount of human labor involved in those things. So that's the next frontier. Still, we can show it in the lab. You can find it online, but it's still very difficult to deploy that at scale, reliably and safely in the industry. But certainly robotics and AI has the capability and we have the capacity to do so. So that's, for us, a key next step as we build our robots. And it's closing really the loop between the digital and the physical world through robots.
And that's what we also love to do at Siemens, to connect the digital and physical world. So Peter, thanks so much for your time, for sharing what you're passionate about, for giving us some insights into what ANYbotics is, what you're doing, and what your mission is. And we're almost at the end of this session. But before we let you go, we would love to play our signature game with you. It's called Authentic Autocomplete. And what I can reveal up front, it's really, really great fun. So for the closing, I'd like to give you a couple of sentence starters and you can finish them. Does that sound good?
Let's do it.
Let's do it. So Siemens is...
Well, Siemens for us is a fantastic partner to bring our robotic fleet, to market. I think we work together great in integrations and scaling, and we leverage the domain expertise of Siemens. So Siemens is a great partner to ANYbotics.
Cool.
Robots can surprise you by performing the task of...
as I mentioned in the beginning, robots just think differently. Robots can surprise you by being extremely accurate, smart, and they can show through AI kind of very intuitive behavior that you wouldn't expect, but it's still a robotic systems. There's a lot of things that robots cannot do. For example, nobody has shown yet that you can take a robot to take the key out of your pocket. This is one of the unsolved robotics tasks. And I think it's being, telling the stories of what robots can do and cannot do. I think that's fundamental to create that category and be transparent around it.
Definitely. And autonomy is?
Autonomy is at the core of our products. We look at robotics really freed up when you have one robot being able to perform the tasks by itself. So one supervisor can look at hundreds of robots. So for me, robotics is not just a remote control car that still the human is in the room, but autonomy is at the core of building an autonomous workforce of robots.
Agreed. And last but not least, and this is a tough one, if I could invent one rule for everyone in the world to follow, it would be?
If I could invent one rule, for everyone to follow, it'd be to be really responsible about the technology you're building. Obviously, the technology we're building, there's always a potential for misuse. We see this a lot on TV and media with drones being used in warfare. For us, we take, big stance on non-weaponization of our systems. We track the robots. We know our customers really well. And this comes, I think, also from, the responsibility that we know we carry also culturally at our company. And I wish that others would follow that rule often as well.
Peter, thanks so much for your time, for being that open, being that clear. I must admit, I'm deeply impressed about, how clear you articulate, the messages, and being such a passionate mind, which we can see and feel throughout the ether of the digital ether. Looking forward to see, the progress and the collaboration, and maybe also meeting somewhere, either one of your kids, robots, let's say, or you in person. Thanks so much for spending time on the Human AI podcast.
Thanks so much. This was a pleasure. Thanks, Alberi and Uli. Talk soon.
Folks, geeks, and robotic enthusiasts out there, connect with Peter, ANYbotics, right? Or with us on LinkedIn. Tell what you like, what we can improve, or what kind of use cases you foresee for ANYbotics. And obviously, stay tuned. There's so much to come, right? Stay bold, committed, and open-minded. And we'll hear us at the next Siemens AI Lab podcast. Cheers.